These are the zombie stars, the cosmic phoenixes of the galaxy, and they are born from the quiet, dense remnants of dead stars called white dwarfs. For decades, astronomers have studied these strange objects, piecing together the story of how a star that has already exhausted its fuel collapsed into a Earth-sized ball of super-dense matter and cooled into a dark, inert cinder can reignite, explode and rewrite the rules of stellar life and death. This is the untold story of the zombie star, the white dwarf, that rises from death. To understand zombie stars, we must first start with the life and death of an ordinary star, like our Sun. Most stars in the Milky Way, about 97% of them, including our own Sun, will end their lives as white dwarfs. When a star like the Sun runs out of hydrogen fuel in its core, it can no longer generate the outward pressure needed to fight against the inward pull of gravity. The core collapses, and the outer layers of the star puff outward into a beautiful planetary nebula, a glowing cloud of gas and dust that drifts into space. What remains is the core, a white dwarf, a stellar remnant about the size of Earth, but with the mass of the Sun. A single teaspoon of white dwarf material would weigh as much as a mountain on Earth, making it one of the densest objects in the universe. Second, only to neutron stars and black holes. A white dwarf is for all intents and purposes a dead star. It has no nuclear fusion happening in its core, no hydrogen, no helium, no energy being created to keep it shining. It simply sits in space, slowly cooling down over trillions of years, radiating its leftover heat into the cold cosmos until it becomes a black dwarf, a completely dark, cold, and inert rock. For a lone white dwarf, this is the end of the line. Death is permanent, but the universe is rarely lonely, and most stars live in binary systems, two stars orbiting each other, bound by gravity. And this is where the story of the zombie star begins. When a white dwarf has a companion star, a strange and deadly cosmic dance begins. The white dwarf's extreme gravity acts like a cosmic vampire, pulling and stealing gas, mostly hydrogen, from the outer layers of its nearby companion. This gas does not fall directly onto the white dwarf. Instead, it spirals inward, forming a hot, glowing disk of material called an accretion disk around the dead star. As more and more gas is stolen from the companion, the accretion disk grows hotter and denser, spinning faster and faster, until the gas slams onto the surface of the white dwarf. This stolen hydrogen builds up layer by layer, covering the white dwarf's dense core like a thick blanket. For years, decades, even centuries, this process continues quietly. The white dwarf, once dead and cold, begins to gain mass. But there is a hard limit to how much mass a white dwarf can hold. A cosmic line in the sand, discovered by Indian-American astrophysicist Subramanian Chandrasekhar in the 1930s. This limit, now named the Chandrasekhar limit, is about 1.44 times the mass of the Sun. If a white dwarf crosses this threshold, gravity becomes too strong for the electron degeneracy pressure that holds the star up, and the star can no longer support its own weight. This is the moment the zombie star awakens. When the white dwarf's mass hits 1.44 solar masses, the core suddenly collapses in a fraction of a second. The extreme pressure and temperature ignite a runaway nuclear fusion reaction across the entire star at once. Unlike the steady fusion of a living star, this is a catastrophic, unstoppable explosion, a type Ia supernova. In an instant, the dead white dwarf is torn apart, blasting its material into space at 10% the speed of light, releasing more energy in a single second than our Sun will produce in its entire 10 billion-year lifespan. For weeks or months, this supernova shines so brightly that it can outshine an entire galaxy, visible across billions of light-years of space. This is not just a stellar explosion. It is the resurrection of a dead star, a zombie star, bursting back to life in the most spectacular way possible. Astronomers first observed these explosions centuries ago, but they did not understand their origin until the 20th century. Early astronomers called them new stars or novae, but we now know that novae are smaller eruptions on white dwarfs that do not cross the Chandrasekhar limit. They are just the white dwarf's stolen hydrogen, igniting on the surface a faint spark, compared to the full supernova of a zombie star. It was not until the space age, with telescopes orbiting above Earth's atmosphere, that we could truly study these zombie stars in detail. NASA's Chandra X-ray Observatory, launched in 1999, has been instrumental in capturing the high-energy X-rays from the accretion disks around white dwarfs and the fiery aftermath of type Ia supernovae. The Hubble Space Telescope has mapped the remains of these explosions, showing the shells of gas expanding into space, while the James Webb Space Telescope, with its infrared vision, peers into the dust-shrouded cores of these systems, to watch the process of stellar theft in real time. What makes zombie stars even more important is their role as cosmic standard candles. Because every type Ia supernova is triggered by a white dwarf hitting exactly 1.44 solar masses, every single one of these explosions has the same intrinsic brightness. This means astronomers can use them to measure distances across the universe, to calculate how fast the cosmos is expanding, and to study dark energy, the mysterious force that is pushing the universe apart and will determine its ultimate fate. In the 1990s, astronomers using type Ia supernovae made one of the most shocking discoveries in the history of science. The expansion of the universe is accelerating, not slowing down, as everyone expected. This discovery led to the Nobel Prize in Physics and proved that dark energy makes up about 68% of the entire universe. None of this would have been possible without zombie stars, the dead white dwarfs that rise again to light up the cosmos and reveal its deepest secrets. The life cycle of a zombie star is a story of cosmic balance and chaos. It begins with a star like our Sun, living a quiet life for billions of years, fusing hydrogen into helium, warming planets, and nurturing the possibility of life. It dies, becomes a white dwarf, a silent remnant of its former glory. Then, gravity takes hold, and it becomes a thief, stealing life from its neighbor to fuel its own rebirth. It crosses a forbidden line, explodes, and scatters heavy elements like carbon, oxygen, silicon, and iron into space elements that will one day form new stars, new planets, and even new life. We are made of stardust, and much of that stardust comes from the explosive death of zombie stars. Every atom of iron in our blood, every carbon atom in our bones, was forged in the heart of a white dwarf that rose from death. Zombie stars also challenge our ideas about life and death in the universe. On Earth, death is final, but in space, death is just a phase. A star can die, lie dormant for millions of years, and then explode back to life in a fireball that shapes the galaxy. This is the magic of astronomy. It shows us that the universe is not just a collection of rocks and gas and stars, but a living, evolving story, full of cycles of creation and destruction, death and rebirth. Zombie stars are a reminder that the universe is far stranger, more wonderful, and more mysterious than we can ever imagine. They are proof that even in the cold, dark emptiness of space, life, or at least stellar life, finds a way. As we continue to explore the cosmos, new telescopes and missions will uncover more about zombie stars. We will study white dwarfs in distant galaxies, watch the process of accretion in real time, and learn more about how these explosions shape the evolution of galaxies. We may even discover new types of zombie stars, white dwarfs, that reignite in ways we have never seen before. Every observation brings us closer to understanding the full story of these cosmic phoenixes, the dead stars that refuse to stay dead. The universe is a vast, endless library of stories, and the zombie star is one of its most thrilling chapters. It is a story of gravity, of fusion, of cosmic theft, and explosive rebirth, a story that connects the smallest atoms on Earth to the largest structures in the cosmos. Please like, comment, share, and subscribe to the channel